Good morning, everyone. My name is Xavier Fernando. Today, I am going to make a presentation on ICT, or Information and Communication Technologies, and Internet of Things, or IoT, in smart cities. As we all know, the Internet of Things is rapidly growing. The number of connected devices has reached almost 50 billion as of now. This slide here shows how the exponential growth happened all the way from 1990 to year 2020. And we have about 7 billion people in the world, and we have about 6 times more devices connecting we all together. And also, if you look the worldwide distribution of this Internet of Things nodes, you can see that this graph shows the geographic distribution, and Far East Asia and China contribute to about almost half of the world's IoT deployment. And total number of industrial IoT sensors are expected to about 36.8 billion, according to this estimate from Juniper Research. Also, this slide shows the different sectors in which IoT is deployed. So as you can see, the first three highest sectors are manufacturing, transportation and logistics, and utilities. And all these three contribute to a smart society or smart cities. And that is followed by other sectors, and also healthcare and energy and natural resources play some significant role. So let us look at what this IoT is and the IoT framework. Right? IoT is essentially a connected loop. Basically, we have sensors or actuators with their own IP address that can be connected to the internet. These are the things. These are called the things, and we have numerous such sensors already in place in our society and in smart cities. And these sensors or nodes need to be connected to the internet. And most of the time, this connection is wireless. So it can be connected to local area networks, or if it is related to our body, it can be connected to a body area network, personal area network, control area network in case of vehicles, etc. So there are so many different types of networks. And these sensors are connected to the network, and the data, collected data, will be transmitted to a cloud, where the data either sent to or received from the cloud, where the data is stored and processed, and then important information or some decisions can be made by analyzing or mining this data. And once these decisions are made, these decisions are transmitted to, say, several devices again, or consumer electronic devices, or autonomous vehicles, or various other outputs where certain actions are made. Right? So that is a control complete loop. Also, those who are familiar with wireless sensor networks probably want to know what the difference between WSN and IoT. The wireless sensor network talks only about the sensors and how these sensors are connected with each other and the routing protocols, etc. However, IoT, on the other hand, provides an end-to-end solution. The data is collected, stored in the cloud, processed, and appropriate decisions are made and actions are taken. So IoT is a complete solution. Right? And as I'm coming from the wireless communication background, we are very much interested to know what kind of wireless networks connect these IoTs and what are their attributes. And in fact, there are three major things we need to pay attention to. One is the data rate, shown here in the y-axis. The other one is the range or the distance. The other one is the power consumption. So typically you can see that Wi-Fi, we are all familiar with Wi-Fi, it can support very high data rate, but the power consumption is also very high. On the other hand, the long-range communication standards such as Sigfox, LoRa, or on-ramp, these can give you several tens of kilometers of range. The power consumption is also low, but their bit rate, on the other hand, the speed will be very, very low. So it all depends on what kind of data rate you need. Some sensors only transmit occasionally and they don't need that much data rate, so they can really deploy some of these systems, whereas the systems that need very high data rates need to go for high data rate systems such as 4G LTE, 5G, or Wi-Fi. Also, if you look at, I talked about the physical devices or controllers, then if you look at the architecture, connectivity and computing, either at the cloud or edge, that means user device, or in between, in fog, and data accumulation, data abstractions, and development of various applications and implementing certain processes. All these are several layers of the IoT architecture. And when I talk about IoT, if I don't talk about machine learning and artificial intelligence, the talk is incomplete. Right? So here we are looking at machine learning is how to interpret the data, how to collect vast amount of data and identify certain underlying rules. So there are supervised or trained machine learning algorithms or unsupervised or blind algorithms. The supervised algorithms typically has labeled or known data. So you use the labeled data to identify the underlying rules, and then you apply the rule to an unknown data. However, in case of unsupervised or blind machine learning, you really have to learn everything from unknown data. So that is much more complicated and complex. Also, when you learn the machine and you come up with certain rules, and artificial intelligence is really an ultimate way to make complex decisions based on these interconnected devices, the huge amount of data using the machine learning algorithms that has identified the underlying connections or relationships. Right? And also now we are talking about Industry 4.0, in which we actually collect all the data and make several decisions that is related to a smart factory and autonomous systems, where lots of the decisions are implemented. The previous stages of industry 3.0, 2.0, or 1.0 only had partial autonomy, whereas now we are talking about full autonomous industries. Right? And how this IoT and ICT are applied in a smart society or smart city. So there are so many different ways you can look into that. A smart society need to have so many things that are automatically detected. For example, location-based services. We all know nowadays, lots of services depends on where you are located, which part of the city, which neighborhood, and what is the nearest pizza delivery store, from what is the nearest police station or fire station or gas station, etc. So all these location-based services and smart services or value-added services will help us to realize a smart city environment. And IoT, sensing the data, sensing user behavior, sensing their location, sensing their speed, all these are very, very important to realize a smart city. And some of the other examples are like smart payments. So you go to an environment where you can use a smart card or your credit card to tap, or even your cell phone to tap, and smart payments. And some of these public transportation systems these days, it can automatically detect your rail pass in your pocket and allow you inside. So all these are coming from IoT implementations of smart payments. And of course, smart healthcare. There is lots of buzz about healthcare. Healthcare requires acquire patients' information and acquire medical data such as X-ray images, MRI images, or various other test data from the patient, storing them and appropriately delivering them to the physician who will either make decisions and prescribe medications. Even the medications can be automatically obtained from pharmacies or some other places using this IoT network. So the IoT and ICT will play a really important place in smart healthcare. And of course, smart buildings, controlling heating and ventilation, smart transportation, smart energy, and smart territory improvement. All these are examples of IoT deployment. So as I was talking about energy, IoT also will play a very important role in smart grids. As we know, nowadays, lots of people are engaged in generating their own electricity using solar power cells or small wind generators, etc. So these generated small scale energy need to be stored appropriately and distributed in the grid. So the smart grid has become a bidirectional energy flow network compared to a unidirectional network that was in the past. So currently, everything related to smart grid need to be redesigned, all the way from protection to load management to load forecast and load distribution, load transmission, everything need to be rearranged because of these microgrids that generate energy using small scale generators. And also, of course, electric vehicles. Electric vehicles are added to the smart grid, and electric vehicles really can transform the way the grid operates. Because electric grid cars can actually store a lot of energy in it. And these batteries can be used as a temporary storage device. So you can actually get energy from the for the smart device, as well as you can supply energy to the smart car. So this can actually help you vehicle to grid and grid to vehicle energy flow that will help you to overall better manage the smart grid. Right? And of course, in transportation, IoT play an imperative role. I already mentioned. Nowadays, they are talking about vehicle to vehicle communications big time and Internet of Vehicles, where IEEE 802.11p or even visible light communication will play an important role, where the vehicles can talk to each other, they can exchange safety information, they can exchange traffic related information, etc. In addition, you can also deploy this in, say, automatic toll collection, say, fleet management, and passenger information management in public transportation systems. There are so many different applications where these IoT systems can be used effectively to optimize the transportation, so that you can realize intelligent transportation systems that will minimize your wait time in the traffic. And of course, autonomous vehicle. This is a classical example of a really smart IoT node. As you can see, an autonomous vehicle is also an IoT node. It has huge amount of processing that need to be done. And basically, these AV automatic vehicles have lots of sensors and lots of processing and lots of decisions to make in a very short time. And these are actually an example of a complete loop of an IoT system. So they really complete the overall loop. And of course, here in this slide, I have listed several hardware that can be used for IoT. You can go through that when you have time. Also, these are different softwares that can be used for IoT. And there are two things we need to focus. First of all, when you have this huge number of nodes everywhere, how do we power them? Right? So battery management can become a very costly and environmentally not sustainable exercise. So people are researching, including myself, how to minimize the energy consumption of these IoTs, how we can harvest energy from the environment, how we can support these nodes by energy scavenging from the environment using either solar, either RF energy, wind, so various other ways. And the other question is spectral sustainability. When we have these many large number of nodes, and all of these require their own radio spectrum, how do we support that? Right? How much we can allow spectral reuse? And nowadays, people are researching about terahertz frequency band and even optical wireless communication, such as visible light communication, in order to overcome this spectral sustainability. And also most of these future systems will be very, very smart, and they will sense the environment, identify the radio environment, and decide which spectrum will not cause harmful interference and use that particular spectrum. It's called the cognitive radio systems. So these are also on the rise, right? Of course, the most important thing about this realization of this IoT is security and privacy. It is very, very important to know how much security and privacy can be maintained. And the amount of money that spent on the security and privacy is really high, all the way from, say, to exceed 1 trillion almost by 2021, but still some security breaches do happen. So there is it is an increasing area of concern, and there is lots of research happening there. And I'm sure that in the future, security protocols will be protecting us. And finally, essentially, I want to talk about 3 I's: instrumentation, IoT nodes, interconnection where ICT comes into play, and intelligence where all this machine learning and AI algorithms will play a role. And all these 3 I's should be used to serve the humanity, right? Only for the good purpose, to serve the humanity, not to destroy or not for any malicious intentions. So as long as we use the technology to serve the humanity and help to improve the quality of life and have a peaceful life, I think we are all, that is the direction we want to go. Okay. So finally, a word about Rising Communication Labs in Toronto, Canada. Where I founded this lab, and I have been working with so many students and industry partners and the government for last 20 years. And if you ever want to come to Toronto, you can always contact me. Thank you very much for this opportunity.